All right. We're going to do stoichiometry, and basically it's just doing all the math behind an equation. All right, we're going to start with how many Cl minus do you need for x moles of Na plus? So we have, let's say, 3 moles of Na plus. How many moles is Cl minus? So we know we have 3 moles Na plus. We know we have a 1-to-1 ratio, therefore 1 mole Na plus is 1 mole Cl minus, which means 3 moles All right, now we're going to do grams to moles. We're going to do grams to moles, and let's say we have 13 grams Na plus. How many moles of NaCl are we going to have? So if we have 13 grams of Na plus, that means 22.99 grams is 1 mole Na plus. 1 mole Na plus is equal to 1 mole of NaCl. Multiply the top and then divide by the bottom. 13 divided by 22.99 equals 565 moles NaCl. All right, and the last one we're going to do is from grams to grams. We have 20 grams of Cl minus. How many grams of NaCl is produced? So we have 20 grams Cl minus. Five. 1 mole, 1 mole, 1 mole, NaCl, 1 mole, NaCl is going to be 58.4 grams, which then equals, you multiply top and divide by bottom.
So continuing on with stoichiometry, we have a new equation this time. We have 2H2 plus O2 yields 2H2O. And for our first problem, we're going to do grams of hydrogen gas to grams of water. So we're going to start with, let's say, 5 grams, 2 grams of H2. And we need to know how many grams of H2O will be produced. So we'll start by putting in what we know, which is 2 grams of H2. And H2 is molar mass per grams per mole is 2 grams, 1 mole H2. And then for every mole of H2, for every 2 moles of H2, there are 2 moles of H2O produced. for every 1 mole of H2O, there's 18 grams produced, or 18 grams per mole. So then the way T-charts work is you just multiply across the top and divide by everything on the bottom. So we'll take 2 times 1 times 2 times 18, giving us 72, and we'll divide it by 2 times 2, or divide it by 4. Which will give us 18 grams. That's 18 grams of H2O produced for every 2 grams of hydrogen gas. Okay, and for the next problem, we're going to take moles of oxygen and see how many grams of hydrogen gas are needed. So let's say we start with 2 moles of oxygen. We need to know grams of hydrogen gas. So we take what we know, 2 moles of oxygen, and we know the mole-to-mole ratio is 1 mole of oxygen gas to every 2 of hydrogen. So we'll plug that in, 1 mole of O2 for every 2 of hydrogen gas. And for 1 mole of hydrogen gas, there's 2 grams. So then again, we just multiply that out. We've got 2 times 2 times 2 for the top, divided by 1 for the bottom, which gives you 8 grams of hydrogen gas needed for every 2 moles of oxygen gas.
All right, we have a slightly harder equation this time. It's a combustion equation. So you're going to have carbon and hydrogen and oxygen in your reactants, and you're going to have CO2 and H2O in your products. So first we're going to decide how many H2O if we have, say, 25 grams of C2H6. So how many grams of H2O do we get? So we have 25 grams C2H6. And then find the molar mass, 34, which is going to be 34 grams, which is 1 mole C2H6, which means that for every 2 moles of this, we get 6 moles of H2O. So 2 moles C2H6, we get 6 moles H2O. And we know that for every 1 mole H2O, we have 18 H2O. So now that we know we have 18 grams, we do multiply top, then divide by multiply bottom. 25 times 6 times 18 equals 27,000 divided by 34 times 2, which gets us 39.7 grams H2O. Next, we're going to do, we have, let's say, 24 grams of CO2. How many moles of O2 did we use to produce that? All right, so we have 24 grams CO2, and that means 44 is the molar mass for CO2, which equals 1 mole. And then we have the 4 to 7 ratio here, so 4 moles CO2 equals 7 moles of O2. And we don't have to go And we don't have to go any further since we're just looking for moles. So that is going to equal 24 times 7 divided by 44 times 4, which gives us 0.95 moles of O2 needed to make 24 grams of CO2.
Now we're with our last equation. It looks scary, but it's the exact same process as all the other ones we've done so far. Simple stoichiometry rules. So for the first problem, we're going to say we have 10 moles of H2O, and we want to know how many moles of MnO4 minus that will produce. So we start out just like we did with the other ones. We start with what we know in the top, which is 10 moles of H2O. We know that for every 4 moles of H2O, 1 mole of MnO4 minus is produced. 4 moles of H2O, 1 mole MnO4 minus. That's all we have to do for this T-chart, because we're just doing a mole to mole. So, we simply take 10 divided by 4, which is 2.5 moles MnO4 minus produced for every 10 moles of H2O consumed. And the very last problem we're going to run through is a gram-to-gram conversion. So we're going to say we have 20 grams of Mn2+, and we want to find the number of grams of H+ produced. So we start with what we know, which is the 20 grams of Mn2+. And the molar mass of Mn2+ is 55 grams per 1 mole. And then we know that for every 1 mole of Mn2+, there are 8 moles of H+. And then we know that for every 1 mole of H+, it is 1 gram. And so then, just like all the other problems we've been doing, we simply multiply the top and divide by the bottom. So we take 20 times 1 times 8 times 1, which gives us 160, and we divide by 55.